How do we add numbers that are not in base 10? So let's say we want to add 23 and 13 that are in base 4. If you did regular addition, the answer would be 36. But that is incorrect. The reason being 36, the second digit, or the digit in the first position from the right, is 6. But we all know that a base 4 number cannot have digits that are bigger than 3. So that's definitely the wrong answer. So how do we go about doing this? Remember, when I first did Hindu, you could watch the video, Hindu Arabic numeral system, I wrote 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I picked one and put it in front of what I had previously. We are going to do the same thing. It's better this way. With practice, you would be able to do this in your head. So base 10, base 4. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Let's go all the way up to 10. So the first 4 places, not a big deal. 0, 1, 2, 3. The next one is 4. So when you get to 4, we go back to 1, the next digit, and add 0, 1, 2, 3. So 1, 0, 1, 1, 1, 2, 1, 3. Now that you've gotten to 7, we go back, pick 2. So 2, 0, 2, 1, 2, 2. Naturally, the next one would be 2, 3. You may say, well, what would happen when you get to bigger numbers? Well, we're going to cycle through the same way. You will add a 3rd digit and you would proceed the same way. So here I have 3 plus 3, which is 6. And I know 6 in base 4 corresponds to, 6 in base 10 corresponds to 12 in base 4. So once I recognize that, I would do regular addition. So 3, 3, 6, writing it in base 4. 2, put 1 there. So regular addition, 1 plus 2 plus 1 is 4. But I can't have 4 because the digits have to be less than 4. So if I go back and look at my base 4 number corresponding to 4, it is 1, 0. So we will have 1, 0. So the answer is 102 in base 4. So when we add 23 in base 4 and 13 in base 4, we end up getting 102 in base 4. So we want to add 35 and 27, or let's not do 27. Let's do 24. Base 4, base 4. So we're going to add 35 and 24 in base 4. 5 plus 4 is 9. 9 cannot be in our answer because we're dealing with base 4. So I go through the simple table that I wrote, and I realized that 9 in base 10 corresponds to 21 in base 4. So 5 plus 4 is 9, but I write it in base 4. So 1, put 2 up there. 3 plus 2 plus 2 is 7, and 7 is also not possible because we are dealing with base 4. So the number, the base 4 number corresponding to 7 in base 10 is 13. So I would have 1, 3. So when I add 35 and 24 in base 4, the resulting answer is 131. Key thing to remember is when we add stuff, we're just adding the usual way. However, when the number exceeds our base requirement, we go back and look at the table and adjust accordingly. Let's add 321, 452, both in base 5. Of course, with practice, you can do this mentally, which is why we did that in the previous video. So even though I wrote it out, with practice, you'd be able to do it mentally. So I'll go ahead and write this table because it's very useful. So base 10, base 5, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first 5 digits, not a problem at all. We could simply write 0, 1, 2, 3, 4. When I get to 5, I go back, pick the next digit, which is 1, and put that digit in front of 1, 2, 3, 4. So we would have 1, 1, 1, 2, 1, 3, 1, 4. Since I ran out of the 4 digits, I'll go back, pick 2, and put it in front of 1, 2, 3, 4. So 2, 1, 2, 2. You can always verify the answer. So let's see if I did that 2, 2 part correctly. So, or am I converting it to base 4 or base 5? Got to go back a bit. I think I made a mistake here. So we've got to pick one, and it didn't look right to me. So pick one, the next digit, and start at 0 and add it as the second digit. So you'll have 1, 0, 1, 1, 1, 2, 1, 3, 1, 4. You ran out of those 5 places. So I go back, I pick the number 2, and I add it to the number 0, 1, 2, 3, and 4. So we will have 2, 0, naturally you'll have 2, 1, 2, 2, and so forth. Let's see if I did this right. Let's pick 9 and 14. So base 5, 14. I want to convert it to base 10. We know how to do this. 4 times 5 raised 0 1 times 5 raised 1. So 4, 5, if I add, I get 9. So 9 is in base 10. So instead of going through the division process, the multiplication process, I'm just cycling through by writing that out. So 1 plus 2 is 3, definitely less than 4, not a problem. 2 plus 5 is 7. 7 exceeds 5. However, I know 7 corresponds to 1, 2 in base 5. So I'm going to put 2 here, 1 up there. 4, 3. 3 plus 4 plus 1 is 8. 8 exceeds 5. But I know 8 in base 10 corresponds to 13 in base 5. So I'm just going to put 1, 3, 2, 3. So if you add 321 and 452 in base 5, the answer is 1323 in base 5. So I'm going to start with base 10. Then go to base 7. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, just for good measure. The first 6 digits, not a problem at all. At the moment we hit 7, got to think twice. So we have to pick the next digit in our base and add it to the values in red as the second digit. So we will end up having 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, and 1, 5. You can always verify your answer. So the 0, 1, 2, 3, 4, 5 comes from the red numbers that I have. And 1 is the value that I chose with the arrow. So the next number would be 1, 6. We can't have 1, 7, so we will go back to 2, 0, 2, 1, 2, 2, and so forth. We don't need all that. So 2 plus 4 is 6, and it's well within our margin. So 6 is fine. 3 plus 6 is 9. 9 cannot be in base 7. So I go and look at it. Base 9 corresponds to, 9 in base 10 corresponds to 12 in base 7. So 2 and 1. I end up having 12. 12 in base 10 corresponds to 15 in base 7. So that would be 15. So when I add 632 in base 7, 564 in base 7, the answer is 1526 in base 7. So I am going to first write out my table so that things are easy. Once again, in practice, we don't sit and write this out. We can do this using the computer, but we want you to understand the underlying concept. So base 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, 12, 13. So the first 8 numbers, not a problem. 9 cannot be in a base 9 system. So I go back, choose 1, and add 1 to the previous digits in red. By add, I mean appending it to the existing digit. So that would become 1 0, 1 1, 1 2, 1 3, and 1 4. So those values are simply coming from the previous numbers that we have in red. So now that we sorted that out, 4 plus 5 is 9. 9 cannot be in the answer. So I look at the table that I created. 9 in base 10 would correspond to 10 or 1 0 in base 9. So 0, 1. 8 plus 6, 14, and I'll have 15. So naturally, I have up to 13. You can see 13 base 10 became 14 in base 9. You went down in base here. You went up in the corresponding number. So 15 in base 9, base 10 would correspond to 16 in base 9. So 6, 1, 16 in base 10 would correspond to 17 in base 9. 14 in base 10 would correspond to 15 in base 9. So now that I did this mentally, I'll show you what I mean. So base 10, base 9. So 14, 15, 16, 17, so you can, and 18. Here you go to 13. 13 corresponds to 14. Now I'd have 15, 16, 17, 18, 1 less. But do keep in mind, this is where things change. 18 cannot correspond to 19. So you go back, pick the digit 2, and then add it to the previous one that you selected, which would be 1, not 0. So this would start at 2, 1. 19 would be 2, 2. And so on. And we typically don't deal with large numbers when we do it manually. I take that back. You would add it to 0 and cycle through. So, oops. So that should be 0, 1, and ... You can always verify it by converting it back. So to add those two base 16 numbers, I am going to write out base 10 . Keep in mind from last time, I can't simply go back and add 1 and cycle through the way like I did in the previous case, because it is going to go past the values that we have. So base 16, by values that we have, in the sense that if I cycle through, I would exceed 16 and it would not make sense at all. So the first 9 numbers, not a problem. So I can't simply cycle through like I did previously because I'll end up getting the same numbers. So what we do is we end up calling or use letters A, B, C, D, E, F. That's what we did last time. So we have B. B corresponds to 11. And I want to add 11 to 4, which would give me 15. So 15 is simply F in hex system or base 16. So F. I just put F so I don't have to carry anything forward. 3 plus 9 is 12. So I can simply put C. I don't have to carry anything forward like I did in the previous bases. 5 plus 6 is 11. So I can just put B. And you can see the 16 base system is sort of easier compared to the other systems. If I have to write for 16, I will pick A over here and cycle through from 16 onward. So I would write it as A0, next one would be A1, A2, A3, and so forth. And adding in this base 16 is relatively easier compared to other bases because I don't have to carry something forward to the next step in addition. So mention base 16 is easy to manipulate, just like base 2, which is why we use that in computer systems a lot. So C plus 1, C we know is 12. 12 plus 1 is 13. But 13 is simply D in hexadecimal. So I'll put D. 2 plus 9 is 11. 11 in hexadecimal is just B. B is 11. 11 plus 1 is 12. 12 in hex system is C. Hex system, hexadecimal, they all correspond to base 16. 4 plus 10 is 14. 14 in hex is E. So ECBD base 16. So multiplying bases other than 10. So let's say we start with 34 in base 5. We multiply with 3 in base 5. So we do regular multiplication in the sense you're simply doing 34 times 3. But we know that we can't exceed a certain value because it's base 5. So 4 times 3 is 12, but 12 is not in base 5. So we could always do a base 5 table And we can recognize that 12 is simply 2, 2 in base 5. So anytime we are multiplying, it is best to create this table. So all of those would be 0. Those would be 0. So 1, 2, 3, 4, not a problem. 2, 3, 4, not a problem. 4 is not a problem, but 6 is. So 6 in base 5, we have to go back and write it out our usual table. 0, 1, 2, 3, 4, 5, 6, 7. Keep on going. It's base 10 and base 5. The first 5, not a problem. 0, 1, 2, 3, 4. We have to cycle, pick the next digit, and do 1, 0, 1, 1, 1, 2. 8 would be 1, 3. 9 would be 1, 4. And 10 we cannot represent because we will exceed the required base. So let's see if we can fill the table up with what we have. 2 times 3 is 6, but 6 would correspond to 11. 2 times 4 is 8. 7 is 12, so 8 must be 13. 3 times 2 is 6. We know 6 is 11. 3 times 3 is 9. We know 8 is 13, so 9 has to be 14. 10 would be 15. 11, we have to cycle back. So let's go ahead and write it out. So 8, 9, 10, 11, 12, 13, 14, 15, 16. So we will have 13, 14. We can't have 15 because that's not possible in base 5. So we cycle back, pick the first digit. So 2, 0, 2, 1, 2, 2, 2, 3, 2, 4. That's the maximum we can go. 7, 8, 9, 10. The next one is 15. I can't put 2, 5. So I go back, cycle again. 3, let me use a different color. 3, 0, 3, 1. The next would be 3, 2, 3, 3, and so forth. Once again, when we do the manual stuff, we are not going to deal with big numbers. 3 times 4 is 12, but I know 12 is 22 in base 5. So same here, 4 times 3, 12, which would be 22. 4 times 2 is 8. 8 is 1, 3. And 4 times 4 is 16. 16 is 31 in base 5. Now that we got that sorted out, we can do a regular multiplication in base 10, but just replace it with values that we have in this base 5 table. So 4 times 3 is 12. So 12 corresponds to 22 in base 5. So 2 and carry 2. 3 times 3 is 9. 9 plus 2 is 11. 11 corresponds to 21 in our table. So we would simply have 21 put in place for 11. So when we multiply 34 in base 5 with 3 in base 5, the resulting answer is 212 in base 5. So writing the table out is always useful. With practice, one can do this mentally. So we can write out our usual table. Base 10, base 2, 0, 1, 2, 3, 4, 5, 6, 7. So 0 is fine, 1 is fine, but 2 is not, because it'll exceed the limit that we have. So we have to cycle back. 1, 0, 1, 1. 4 is not fine because we can't do 1, 2. We have to cycle back, but only this time we have to put it in position 2. So easier way to look at this is to call that as 0, 0 and 0, 1 to avoid confusion. So because we're dealing with binaries. So for 4, I'm going to go back, choose 1, and add it to the third, or append it as the third digit to the previous numbers. So I'll end up having 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So now that we have that sorted out, we can directly multiply the bases that we have, or the numbers in the bases. So 11 in base 2 multiplied by 1 in base 2. Here, nothing is going to change because similar to multiplying 10 times 1. So 1 times 1 is 1, well within our range. 1 times 1 next is also 1. We get 1, well within our range. So the answer is 2. Excuse me, 1, 1, base 2. I wrote the table out so you can see how we can cycle through digits. So 21 base 4 multiplied by 3 base 4. So we have the base 4 table already, so things are going to be easy for us. 3 times 1 is 3, that's perfectly fine. 3 times 2 is 6, but 6 in base 10 is 12 in base 4, so it would be 1, 2, 3, base 4. So usual multiplication, 2 times 1 is 2. 2 is a valid digit in base 4, perfectly fine. 4 times 2 is 8. 8 is not possible in base 4, but we know 8 corresponds to 20, or 20 in base 4. So I'll simply put 20 base 4. So I'm just going to multiply 543 base 6 with 5 in base 6. As always, it is good to write the base 10 in corresponding base 6. Let's see, we may have to go all the way up to 25. So let's see if we can do this mentally. So I don't want to write all of it. So 5 times 3 is 15, and we want to do it in base 6. So how would we go about doing 15 in base 6? Well, the first number that is less than 15 would be 12. So that would be in position 2. And then we need to have, so 6 raised 0, 6 raised 1, 6 raised 2, 6 raised 3. So we have 2 digits, because 6 is less than, 3 digits, I mean. 6 is less than 15, so we have to multiply 6 by some number. So 6 times 2 is 12, and that will leave me with 3. So 3 times 1 would be 3. So, and 12 plus 3 would be 15. So 5 times 3 is 15. 15 in base 10 would be 23 in base 6. So we will go back and write it as 3, carry over 2. So 5 times 4 is 20. Then I have 22. So 22 is less than, 12 is less than 22. 36 is not. So once again, we would only have 2 digits. So 6 times 1 plus something multiplied by 6 raised 0, which would simply be 1. So if I put 3 here, I will get 18, and 1 there, 19. So it can't be 1. So can't be 2, can't be 3. But what if I put 4? 3 times 6 is 18. 4 times 1 is 4. 18 plus 4 is 22. So 22 in base 10 is simply 34 in base 6. Because this, with practice, once again, you could do this mentally. I don't want to just run through, which is why I'm writing it out. So we have 34. I'm going to put 4 here, carry 3. 5 times 5 is 25. 25 plus 3 is 28. Again, 28 is greater than 6. But we can't go to the third digit, which is 36. And it should be bigger than 28. So we just have to stop at the second one. So if I put 4 here, 6 times 4 is 24. If I take 24 out of 28, I'm left with 4. So I'm just going to put 4 there. So 28 in base 10 is simply 44 in base 6. So I can simply put 44 there. So we want to multiply the numbers in base 8. So 3 times 4 is 12, but 12 in base 8 will be or can be computed using this approach. So the maximum digit that we can go is the second digit, which is 8. So if I account for 8, I'm left with 4. So I will write it as 8. Some number value multiplied by 8 raised 1. Some value multiplied by 8 raised 0. So if that is 1, then I've accounted for 8, leaves me with 4. 4 times 1 is 1. 8 plus 4 is 12. So 12 in base 10 would correspond to 14 in base 8. So I'm going to put 4 here, carry 1. 4 times 2, 8. 8 plus 1, 9. So 9 in base 2, base 8. Once again, we have to do it using the sequence here. So some value multiplied by 8 raised 1, and some value multiplied by 8 raised 0. So we are going backward or backwards in the base from 10 by 2. So technically 9 will get added by 2. Let's see if we get that. So 1 times 8 is 8. 1 times 8 raised 0 is 1, which is 8 plus 1, 9. So nine in base 10 would be 11 in base 8. You can see we went back in base by 2, but we move forward, or we add by 2. Now, this will get a bit tricky once you get to the higher values, but for simple ones, you can easily remember it this way. So 9 corresponds to 11 in base 8. 6 times 4, 25. 24. 24 plus 1, 25. Once again, we can only go up to 8 because 8 squared is 64, and that would exceed 25. So I'm going to put 8 raised 1 and 8 raised 0. If I put 3 there, 8 times 3 is 24. That leaves me with 1. So 1 times 8 raised 0, which is 1. 24 plus 1 is 25. So 25 in base 10 would be equal to 31 in base 8. So I simply put 31 in base 8. So we want to multiply 131 in base 9 with 8 in base 9. So best to write it 9 raised 0, 9 raised 1, 9 raised 2, ... 9 raised 0 is 1, 9 raised 1 is 9, 9 raised 2, 81. So we can only go up to 2 digits when we get to the second step in multiplication. First one is fine. 8 times 1, 8. Not a big deal. 8 times 3 is 24. So 24 base 10, I can write it as 2 times 9, 18. 6 times 1, 6. 18 plus 6 is 24. So we will have 2 and 6. So 24 base 10 would be 26 in base 8, going forward by 2. So 6 and 8 times 1 is 8. And we have 2, which would be 12. So 12 in base 10 would be equal, it's not 12, I'm sorry, it's 10. 8 times 1 is 8, and I carried over 2, so it's actually 10. 10 in base 10 would be equal to, for some reason, my mind got stuck on base 8. Did we do a base 8 problem? That's why. So we're doing base 9. So 8, 24, base 9, 10, base 9, 9 raised 1 plus 9 raised 0, 1, and 1 will give me 10, adding 1. So we will end up getting 1 and 1 in base 9. So here we want to multiply 216 in base 7 with 5 in base 7. So 7 raised 0, 7 raised 1, 7 raised 2, 7 raised 3, ... 7 raised 0 is 1, 7 raised 1 is 7, 7 squared, 49, 7 cubed, 343. And keeps on going. So we can only go up to 2 digits in this problem. 6 times 5 is 30, and we want to write it in base 7. I can only go up to 2 digits, so some number, some value multiplied by 7, some value multiplied by 1. So 4 times 7 is 28. 2 times 1 is 2. So 28 plus 2 is 30. So have 42 in base 7. So 2, carry 4. 5 times 1, 5. 5 plus 4, 9. 9 in base 10. Again, we can only go up to 2 digits. So 1 times 7 is 7. 2 times 1 is 2. 7 plus 2, 9. So in base 10, we have 9. And in base 7, it would be 12. So 2, carry 1. 5 times 2 is 10. We have 1 already, so 11. 11 in base 10. Again, we can only go up to 2 digits. So 1 times 7 is 7. 4 times 1 is 4. 7 plus 4 is 11. So that would result in 1 4 in base 7. So 1422 in base 7.